Alright, so we're going to look at some word problems here. We're just trying to get figured out how we can make a word problem into an equation. Here, for example, it says that Sean sold 4 more boxes of candy for the school fundraiser than Marta did. The sum of the boxes they sold was 22, and how many boxes did each of them sell? So, first of all, I'm going to read the problem for understanding. So when I go through the question, I like to underline things that are important. So first of all, I see that Sean sold 4 more boxes than Marta. The sum of the boxes they sold was 22. Then we want to know how many they each sold. So I underlined some important words. Then we have to pick our variables. So let's say x. Okay, what should we let x equal? Okay, so if x is Marta's boxes, then we can say that Sean's would be x plus 4. Because if Marta's boxes represents x and then Sean sold 4 more, then Sean is at x plus 4. So now how do we do this next part where the sum was 22? Alright, so once we put Marta's boxes with Sean's boxes and then we put equal 22 because together they sold 22 boxes. So that would be our equation. But now we want to know how many boxes they each sold. So now we need to solve the equation. So really what I have here is x plus 4 equals 22. So to solve this, I see I have 1x here and 1x here. So when I add them together, how many x's do we have? 2. So I have 2 x's plus 4 equals 22. Now I'm going to move my 4. How do I move it? Subtract. So we get 2x equals 18. And then finally we'll divide out that 2. So x equals 9. So x equals 9 is one of my answers. So 9 was Marta's boxes that she sold, but then Sean sold 4 more than that, which means Sean would have sold 13 boxes altogether. All right, let's look at our next example. I actually think we did this question already when we did our linear functions in chapter 6. This one says that a machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Write an equation. Never mind, we were on the wrong example. Let's go to example 2. Here we have a collection of 33 coins consisting of nickels, dimes, and quarters. It has a total value of $3.30. There are 3 times as many nickels as quarters and half as many dimes as nickels. How many coins of each kind are there? Okay, so let's say that x is quarters. But then if there's 3 times as many nickels as quarters, how would we represent nickels? There's 3 times as many nickels as quarters. So we could say then for nickels that it's 3 times x, so 3 times the amount of quarters. But for dimes, it's half of the amount of nickels. So we take half of 3x. So you could write that as 3x over 2 for dimes. Okay, so since there's 33 coins altogether, that means we take the x and we add it to the 3x and add it to the 3x over 2 and get that to equal 33. So altogether it's going to equal 33 coins. Now remember that 3x over 2, if you divide the 3 and the 2, you get 1.5. So this is really like 1.5x. Now they're all like terms. So I have 1x plus 3x plus 1.5x. So that would be a total of 5.5x equals 33. Now how do I move the 5.5 over? Divide it. So that means that x should equal 6. Right. So if there's 6 quarters, then the nickels is 3 times 6, so there'd be 18 nickels. And in the dimes, there's half as many as nickels, so that's 18 over 2, so there'd be 9 dimes. Now what the heck does it have to do with the $3.30? Well, if you converted these to dollar amounts, you would see that they add up to $3.30. So 6 quarters is $1.50. 18 nickels is 90 cents. And 9 dimes is another 90 cents. So if you added these all together, you get $3, is the time, $3.30. So again, you can check your answer with that second piece of information. All right, let's take a look at the third example on your handout. And this one we have two different people we're talking about. We're talking about Mike and his grandpa. It says that their ages added together is 68. So that means that M plus G would equal 68. So Mike's age plus his grandpa's age would be 68. Now there's something else we know. We know that in 3 more years, Mike's grandfather will be 6 times as old as Mike was last year. So let's figure that one out. Okay, so if we take grandpa's age and add 3, that means in 3 years from now, it's going to equal 6 times what Mike's age was last year. So now let's actually simplify this a little bit. So we'd have G plus 3 equals 6M minus 6, because I can multiply the 6 into both the M and the 1. And then I'm going to subtract the 3 over here and just get grandpa's age on its own. So 6M subtract 9. So that means grandpa equals 6 times Mike's age subtract 9. So where we're going with this unit is I have 2 equations here. I have that Mike's age plus grandpa's age is 68, and that grandpa's age is 6 times Mike's age minus 9. So what we do in this unit is a process called substitution. So I can say that then Mike plus 6M minus 9 equals 68, because this is like grandpa's age. So I can trade 6M minus 9 in for grandpa's age in my other equation, because I know that grandpa is 6M minus 9. So all we have to do then is combine our like terms. So we have 1M and 6M is 7M minus 9. I'll add my 9 over. So we get 77. Divide out that 7 from the front. So that means M is 11. So Mike is 11. Now if Mike is 11, then 11 plus grandpa's age equals 68. So if I subtract the 11 from 68, we get grandpa is 57. And so that's one method on how you solve when you're given 2 equations. Don't worry if you don't understand that right now. That's what we're taking all week to learn how to do.